Okay, so the next two questions, we're going to move down to some other equations. So now we have when a potential difference is a voltage of 18 volts, so V equals 18 volts, is applied to a given wire, it conducts 0.35 amps of current. So current I equals 0.35 amps. What is the resistance of the wire? So I want to find R. Okay, so you can see the pattern of what I'm doing. Whenever I read a word problem, every time there's a number, I take that number and put it beside the symbol for that number, and then it's easier for me to select the equation that I want. So if I look at the side, I've got V and I've got I, and I want to find R. So if I look at the equations that I have, the easiest one to use here is the one that's in yellow there. V equals I times R, just Ohm's law. V equals IR. So I want to solve for R, given V and I. So I'm just going to divide the I down that side. So it's just going to be 18 volts over 0.35 amps. And I get, hang on, I'm going to look at my numbers, 51.4 ohms. Okay, so that one was pretty much as easy as you can get. Just a tiny bit of algebra, throw it in your calculator, and you got it. All right, let's go down to the next one. When a potential difference of 12 volts is applied to a wire 6.9 meters long and 0.33 millimeters in diameter, the result is an electric current of 2.1 amps. What's the resistivity of the wire? Okay, so a potential difference of 12 volts, so V equals 12 volts, is applied to a wire 6.9 meters long. L, length, is equal to 6.9 meters, and 0.33 millimeters in diameter. So the diameter, just like we did in problem 2, is 0.33 millimeters. Convert that to meters, so it's 3.3 times 10 to the minus 4 meters. The result is an electric current of 2.1 amps. So I equals 2.1 amps. And we want to know what is the resistivity of the wire. So resistivity, the symbol is the Greek letter rho. So what we're trying to find is rho. So we've got V and I and L and the diameter. And we know from problem 2 that once we have the diameter, we can get the area. Okay, so what do we have? We want to get the resistivity. Now, the only equation that I have here that's got the resistivity in it is R equals rho L over A. So I want to use R equals rho L over A to find rho. So rho is going to be equal to, rearrange it, so times both sides by A, RA, and then divide by L. So I've got the A I can get from the diameter, the L we were given, but I need to know the resistance before I can find the resistivity. So how can I find the resistance? Well, I'm given V and I, so I can do just what I did in the previous problem. So let's go ahead and do that. So R is equal to V over I. So that's 12 over 2.1, which is 5.714 ohms. And at the moment, I'm not going to round this resistance off to the right number of significant figures because I'm going to use it in another calculation. All right, so now I'm going to take that resistance. I can plug it in there, but first I need to calculate my area. So area is pi r squared, where r is d over 2. So it's pi times 3.3 times 10 to the minus 4 over 2 squared. So my area is, again, it's going to be a really small number, 8.553 times 10 to the minus 8 square meters. Okay, so now I've got everything I need to plug into that red equation there. So resistivity rho is equal to R A over L. So my resistance, 5.714 times my area, 8.553 times 10 to the minus 8, and divide by the length, which is 6.9 meters. and I get a resistivity. And resistivity should always be a pretty small number for a conductor. So I get 7.8 times 10 to the minus 8. And the units for resistivity are ohm meters. Okay, so again, an equation, just a little bit of algebra rearranging. This is sort of a two-step problem because first we had to find R, but it's pretty straightforward.